Everyone, today with What's Kraken, I get to speak with someone I've been looking at for a while now, none other than Dr. Ewelina Kurtys. Dr. Curtis, how are you?
I'm good, thank you. I hope you too.
Oh, I'm doing great. I'm doing great. And I know we're talking about Final Spark. What is Final Spark?
Final Spark is a startup which is building computers from living neurons. So we have prototypes now, but the objective is to build living computer from living neurons.
Okay, so living computer. So this is actually a biohybrid computer and not like a brain interface, right?
No, this is a real computer which will be at the heart, which will have living neurons. But there is no interface special, for with the brain.
Interesting. So you're talking about living neurons. Where do those neurons come from then?
So this is a good question everyone is asking. So
Thank you.
neurons are derived from human skin. You can buy induced pluripotent stem cells, which are
Okay.
from human skin. They are
Right.
commercially available. And from the stem cells, you can create any type of cells you want, including neurons.
Including neurons. Now, how does your neuron interface with the hardware?
So we put neurons on the electrodes. So we basically form such a round structure, which is called neurosphere, and it consists of around 10,000 neurons and is around half millimeter diameter. We put such a bulb of neurons on the electrodes,
Right.
usually on the 8 electrodes. And this is to enable to send them electrical signals and also to receive electrical signals from neurons.
That's very interesting. Now, what got you into thinking this direction?
So the founders of Final Spark, Fred Jordan and Martin Kuter, they have PhD in signal processing, and they've done a lot of stuff in artificial AI.
Right.
And they started Final Spark as a second project after another successful startup, and they wanted to build thinking machine. That is a dream of many engineers to make a
What
thinking
could go
machine.
wrong?
And they tried initially with silicon hardware, of course,
Right.
with traditional methods. They did some fundamental research in artificial intelligence, and the conclusion was that to make thinking machine, you need huge amount of energy because
Right.
digital AI uses huge amount of energy, and this is actually confirmed today when we look at great success of AI
Yeah.
such as ChatGPT. The success is possible because of huge energy spending, which were needed to build such a model, also to run this. So they realized that for a small startup, if they want to work on the true intelligence, they have to approach the problem differently. They have to find something else than digital, and they realized that the best actually substrate to build intelligence could be neurons because they are proven when we look at our heads.
Yeah.
Neurons are proven to process information, to build true intelligence, and also to use very little energy because neurons are 1 million times more energy efficient compared to digital hardware.
That is amazing, and that's true because we see the big AI people starting to build their own power plants now,
Yes,
just
absolutely.
to keep up with the demands.
Yes, because AI needs a huge amount of energy
Right.
today. So there are potentially two solutions for that, either alternative energy sources or
Right.
alternative computing. And we are working on the second road.
The second solution. So with AI, we saw a lot of ethical handbrakes put in, or getting now put in, I should say. What is the guidance for your final spark then?
So this is new technology, so also questions are new, and there will
Hmm.
be for sure another new questions in the future which we cannot predict.
Right.
So for now, we get a lot of questions, for example, about consciousness. People are asking if these neurons can be conscious one day. We of course don't know. Also, there are questions about the sources of neurons, which we already discussed,
Right.
that they are from human skin. We didn't have to kill anyone, and yes, the
You didn't
main
have to.
questions about yes about
You
the
could.
about actually consciousness, and these kind of discussions are also seen in the digital world. Some people also worry about possible consciousness of digital hardware
AI.
or
Yeah.
robots in the future. So these are important questions, and we, of course, we are scientists and engineers, so we are not really competent to answer these kind of questions. So this is why we got in touch with many philosophers who work on philosophy and ethics of technology, and
Okay.
we encourage them to work on this problem also of biocomputing. And we actually found a group in the UK which is planning to do a research project about this, about specifically philosophical questions about this project, but it's not official yet because they have not yet received funding.
Right.
So I cannot disclose yet, but we are working hard on encouraging
You're
and
right.
finding philosophers who would like to work on this. Of
Well,
course, independently
that's
of
a
us.
great plan, though. I mean, that's the great plan because you're doing it before you have to answer,
Absolutely.
because AI did it afterwards.
Yes, this is
Yeah.
very important for us because we want that our work is, of course, accepted by the
Yeah.
society, and we want that all the questions are clarified. So this is why we put this effort.
So you're saying best. I'm not going to hold you to this because the science is pretty new. The best guess is the neurons will not feel anything. They're
Well,
just going to
this is my
exist.
personal opinion, I have to say,
Right.
but I'm not
Right.
philosopher, I'm neuroscientist.
Right. Right.
So, I look at the world a bit differently, maybe, and I look at the facts. And the facts are that
Yeah.
we actually cannot measure consciousness. So, this is something very abstract. This is why this is subject for philosophical research, not for me.
Right.
So I personally don't think so because I think that our consciousness is connected also to our bodies. So what creates a human and our mind is not only just
This
neurons.
sensory
Uh,
input.
but there are many opinions in philosophy also about which are in contrary. So we have to respect
Right.
this, and we think that experts will be much better to answer this kind of questions
Well,
than.
absolutely. And for those who are listening at home, even what medical death is and medical life, it's debate. It's not clear cut. It's a debate.
Oh yes, indeed. I had once a conversation
Yeah.
with the medical doctor who told me that it's really difficult, and
Yeah.
yes, there is a lot of effort actually to measure medical death very
Absolutely.
very precisely because of course it's a huge responsibility for the doctors. Yes, so
Absolutely. And so this is again kind of in the same realm of science. It's going to always be a debate, and I'm really glad you guys are bringing philosophers in because I think that's always an important step that
yes, we think
I
they are
think
much
AI
better
missed
to
at the
answer it.
beginning, and you guys are hitting. So how do they learn? Like, how do the neurons learn? Because I'm guessing, are you just using for energy?
Yes, absolutely. So we know by looking at the human brain that neurons
Right.
learn by changing, connections
Yeah.
between each other. So basically, every day you have some experience, you have also feedback from the environment, and that's
Yeah.
why this is how you learn. And we try to use the same principles in vitro.
Hmm.
So in the dish, when we have our neurons in the lab, and this is actually a huge challenge. So we are still working on that. That our milestone for the next 2-3 years is actually learning in vitro how to modify connections between neurons in vitro by using chemical or electrical stimulation, the same way how they are also stimulated in the brain. Because in the brain, neurons they process information through electrical signals and also
Right.
chemical signals such as different neurotransmitters, for example, dopamine or serotonin.
Now, what is the ultimate goal of Final Spark? What's the current end game of it?
So, ultimate goal is, of course, a general computing device.
Okay.
This will be alternative, but not total replacement for digital computers.
Right.
But, it will be additional computing power for some tasks. We believe, like for example, generative AI
Right.
would be appropriate task for living neurons. So we want to build bioservers. So this will be a central biocomputers which will be available remotely for computation, the same way as today we can connect with cloud computing. So this is what we have in
Really?
mind. This is our vision, and today our laboratory is also available remotely for fundamental research on biocomputing. So also scientists from all over the world can connect just using internet browser, and they can do experiments. They can send signals to neurons and collect information, collect data from neurons.
Really?
Yes.
How does one get in this list? I mean, it can't be open to everyone. It's
Oh
open to a
no,
certain select.
no, because actually we are a small team, and at this stage, it's
Yeah.
still it's a lot of work to keep the
Yeah, I
lab
bet.
going. So we have collaborators. We started
Right.
by inviting universities. We've selected 9 universities from all over the world who had free access. We only want that if they publish, that they mention
To
Final
mention.
Spark. That's all. and we have selected these projects as the most promising projects which we received. So this have free access, which is of course very limited, and we also have first commercial clients. We are very happy about this because people started to write to us. They started to ask us for access to the lab, and currently you can rent access. We have two subscription type
Okay.
for access, and we have first paying clients. We are very proud of this. Yes.
That's an amazing thing. So how long ago did Final Spark start? Like how long
Well,
did it start?
actually, it's a long story because Final Spark was founded already in 2014. But
Okay.
as I said, they started with fundamental research in
Right.
artificial intelligence, which was done on digital computers. And then around 2019, they shifted to living computers, to neurons. And then first, they actually had to learn the basics, how to run the lab, how to actually
Right.
work with neurons in vitro, because that was totally new for them. And then after establishing the lab, they started to do experiments and try to.
Excellent.
Uh,
And when did you come on? When did you come to Final Spark?
well, I think around 5 years ago, I met founders at the conference in London, and I was very fascinated that they went to this difficult field because biology is very difficult. I think it's much
Right.
easier to build something with software or hardware. It's much
Yeah.
easier. It's very easy to make a product and much less risk. And I was very impressed that they were so brave to go to biology because it's really frustrating and difficult. I did my research in neuroscience. I know
Yeah.
that it's mostly things are failing, and you sometimes have some good results, but it's very rare. So most of the time, it's full of failures and a lot of
Yeah.
struggles when you work with biological living tissue, because things are not always working as expected. So I was very impressed by this, and I thought it's really great project because it combines neuroscience and engineering. I did all my academic research in neuroscience after I
Right.
shifted to engineering on the commercial side. So I thought it's perfect
Hmm.
combination for me.
That's wonderful. So what brought you to neuroscience growing up?
Well, first of all, I always wanted to be a scientist.
Right.
Since I heard that there is such a possibility of doing a PhD, I always knew I want to do this.
Nice.
So I was always fascinated with the lab. It was like a play for
Yeah.
children. It's like you would have so many toys to play. So I really
That's
enjoy that.
cool.
Because in the lab you have a lot of stuff, a lot of equipment. You can play a lot. It was a lot of fun for me. And I always thought, first I wanted to be a scientist. After, during my studies, I realized that from all the medical topics, because I
Yeah.
studied pharmacy and biotechnology, so I was more on this medical side, I realized that brain is the most interesting part to study for me. So then this is why I decided to go to neuroscience for my PhD.
That, that's fascinating. When you start as a child and seeing things, when you look back, are you like, I'm so glad I went this way?
Yes, I don't regret
Yeah.
anything. Absolutely, I think it's a great. And anyway, at the end, you change with the topics because, of course,
You do.
when I was young and I was choosing the subject of my studies, of master studies, for example,
Right.
I thought it's so important, and I thought it will define my life, but actually, it's
Right.
completely not, because after you can do many other things. So actually, the studies is only just to maybe socialize with other students, just to get some basics. But later in life, you can do what you want. Anyway, so
I think that sums up my academics as well. Yeah. You
yes,
always start this way. You always think it's the most serious thing in the world, and you're like, "Oh no, that's just a rocket ship
yeah.
part of
Actually,
it.
it
That's a
doesn't
booster
matter
rocket."
if you
Yeah,
studied pharmacy or chemistry or something else. It doesn't matter so much because later, anyway, in life, you can change a lot.
absolutely. And you changed into someone working for Final Spark.
Yes.
Now, for neural computing, where do you think the future 5 years from now? How quick is your timeline? Do you
Well,
know?
we expect this is very long-term project, so it's not
Right.
easy. It's like a quantum computing, it takes many, many years because hardware
Yeah.
is totally different. So also the way of coding will be totally different. We need totally different approach, and it takes time. So yeah, we expect that we can build our bioservers in 10 years. We are currently talking to
Wow.
investors. We are raising 50 million Swiss francs, and with this money we can accelerate. So this would allow us to probably build bioserver in 10 years. It's really a lot of work. Mainly you need, of course, humans to work on that, who are very qualified, who can combine neuroscience and engineering.
Right.
So this is mainly needed for the project. So we expect in 5 years, we hope there will be huge progress. So we hope we can run a basic algorithm. We will later work on scaling also to make bigger structures of neurons, because actually in the lab we are not so much limited. The structure of neurons can have even 100 meters, can be something very, very big. Of course, we
Yeah.
will have to work some engineering around this, how to keep neurons alive. But we hope to build huge structures of neurons. But the computer, we expect to be ready bioserver in around 10 years.
That's a pretty good timeline, honestly, especially since it starts out as an AI, like in the mid 2000s,
Yes.
the 10s, 15s, and then it doesn't start actually as Final Spark until 2019.
Mhm.
That's a relatively quick time in science
Well,
to
we will
get
see.
there.
It's also engineering, because actually this
Yeah.
project is more, I would say, it's still more engineering approach, because we
Okay.
don't try to understand how neurons work. We don't try to really answer scientific questions. We just want to make it work.
You
So
want to
this
make it
is a
work.
little bit different approach, very pragmatic. So maybe that's why we are hoping that it will take only 10 years. And of
No,
course, it will be
that's
huge
good.
revolution. So we think that it will be very profitable, because neurons will be very, very competitive compared to digital hardware, because they're 1 million times more energy efficient.
Great. And now, because there's a biological aspect of this, are you worried that there's any type of disease that can affect, like it would be for a human body? I know neurons are not exactly
No, I wouldn't say so. I think, well, currently we have such a setup in the lab that if neurons die, or they could be sick, like maybe with some contamination with bacteria, we can
right.
exchange them quite quickly.
Okay.
So we don't expect this to be the biggest problem. But of course, it's fragile tissue, and if something bad happens, you have to exchange everything. Yes.
Yeah, because I was thinking like the worst case scenario would be like a super well neurocomputer with dementia. Like, oh no.
Yes,
So you can
it's
just exchange
possible.
any faulty parts in, and they won't really have the brain like
Yes, but
that.
I think that if we will be able to build biocomputer, then this will be easy problem to solve, because if one computer will die, we can easily build another one.
Replace with another.
So
Excellent.
the biggest challenge is to be able to build biocomputer,
Yeah.
to make it work
Absolutely. Absolutely.
properly.
Now, where you are at, I'm not going to ask the direct locations of that, but are there any governmental regulations or pushbacks you're seeing?
No, at the moment not, because it's so new. There are only three companies, to our knowledge. There are only three companies in the world globally.
Right.
One in US, one in Australia, and us in Switzerland.
Yeah.
So it's too early, and also at this stage, it's really hard to find something to regulate, because we do similar research like biomedical. There are living neurons used in labs in all over the world.
Yep.
So there is nothing actually so special at this moment
That's
to
wonderful.
find. But we are, of course, working with philosophers about future questions. So we want to be prepared for possible regulations if that will be needed.
Right. And that's the thing. Like a lot of people get, we'll say, country specific and issue specific without actually realizing what the issue is in reality. They'll hear something like neurocomputing and then they'll think we're creating a brand new living being. You're not.
Not really
You know.
being. We
Yeah.
just want to use neurons, which are building blocks of
Right.
brains. So we absolutely don't want to reproduce living brains. We
Right.
just want to use the same building blocks, because neurons are energy efficient. That's all. We
And
don't.
absolutely. And I think when most people start realizing that, a lot of the ethical questions fall away naturally.
Absolutely, absolutely.
Yeah. And I look forward to this. I love medicine. I biomed's my jam, so I was so happy to see this. Like, oh yeah, I can't wait to talk about this. I
Thank you
asked
so
this of
much.
all my guests, and I'm gonna ask of you. If you can give younger you advice, I'm talking like childhood you, what would it be?
Oh, to have less doubts because when I was younger, I always was hesitating, and I
Yeah.
was afraid that maybe I'm not right. But I think I it was not necessary. So I think to have less doubts and be more sure about what you are doing, and don't worry so much because I worried too much, definitely.
Absolutely. But that's a great way of saying it because you are doing cutting edge science right now. I mean, cutting edge, and I think you're doing younger you proud. I really do. Good
Yes, yes,
job. Where
I
can we
think I'm doing
find?
what I've always wanted to do. So I'm very happy with that.
That's all we can ever ask for, right? Where can we find Final Spark? Where can we find it online, socials? Where can we follow your progress?
What will follow my progress? What
Yeah,
do you mean?
where can we find Final Spark to follow your
Oh,
progress or
absolutely. There are many ways. So finalspark.com, the website,
excellent.
that's a great resource. We have also Discord. Discord is maybe the most active platform. You
Okay.
can find the link to this Discord on our website. We have
Okay.
also LinkedIn page, and sometimes we post on X. But also, I think Discord is the most active.
Excellent. Brilliant.
Of
Well,
course,
there
also
we go.
newsletter. So newsletter also there is a link on our website,
Really.
and there are also forms if someone is interested as a researcher, for example. We encourage people to write to us. We are happy to share materials to everyone who wants to understand a bit better what is biocomputing.
I might have to dust off my PhD and do that. Absolutely. Finalspark.com. And I want to say thank you so much, Dr. Curtis, for
Thank you
coming
so much.
out and talking about it.
Thank
Goodbye,
you.
everyone.
Bye bye.